All right, welcome everyone to our presentation. My name is Kathleen Vobel. I'm the Exchange High Availability PM, and my co-presenter is Lynn Chen. She's the PM lead for my area as well as storage. I want to continue to introduce the rest of our team, which Well, while we're waiting on that to happen, so everyone knows high availability is the principles and mechanisms by which we make sure your databases are highly available in the face of failures from disk to entire data centers. And storage, EZ, is about efficiently storing your data and detecting and correcting corruptions. So here we are. Here's the team. Should we test the, oh, it worked. Yep. Okay. Here's the rest of the team. On the left, we have a picture of us a couple years ago, and on the right, you see we've expanded. Even our building got a little bit of an upgrade. And some of us haven't changed, like literally haven't even changed our shirts. Okay, show of hands, who here noticed the photo editing before I pointed it out? Cool, so it was actually easier for me to use Paint 3D than to get this crowd together in a room, partly because we have a team in Suzhou, China, as well as some remote developers in Oregon and Eastern Washington. So here's our agenda today, pretty simple. You might be a little bit surprised to see optimizing client experience on there, but because I just told you, hey, we're all about backends. But really, we feel that every component of the stack contributes to client experience. And while we're still highly focused on our traditional HA and EZ metrics, this is also important to us. The middle section, we're going to dive deep in some of those innovations that Matt presented on Monday. We've got Big Funnel and MCDB using SSDs. The last one is tips for IT pros, a more hands-on section. So if you've been to an Exchange session, you know we're giving away this book. We're going to be asking questions, so if you answer them, come give us your business card or name and email after, and we'll get you the book. So the first section, this slide you also saw on Monday, which just shows the scale of our business, of our service. And really, it shows that how important it is that we need to optimize because we have so much going on, and also why we track metrics up to the 99th percentile. Because our service is so huge, we will encounter those sorts of things. This again is our footprint slide. The blue dots are our backends, and a lot of analysis goes into the design and placement of these data centers for Exchange, because site resiliency is a big part of our HA story. So we need to make sure that our data centers are in different geographical locations, or at least far enough away so that they have different fault zones. So show of hands, who here in the audience was impacted by any of the natural disasters in the last couple months? The hurricanes, the earthquakes, the fires? Anyone here? Yeah, my heart goes out to everyone involved. So Microsoft also always has to keep an eye out for things like this because we have such a large infrastructure presence and because we have employees across the globe. We want to make sure that everything and everybody is safe. So I'm from Central Florida. I grew up near here. And when Hurricane Irma was on its way, I was tracking it closely because my mom, dad, and close friends are here. So likewise with Hurricane Harvey, Exchange High Availability was keeping an eye on that because we have a presence in San Antonio. So I'm going to walk you through what transpired on the evening of August 25th. At that point in time, it was predicted that San Antonio, where we have a bunch of backends, was going to be hit hard by the hurricane. So we had a decision to make. The first choice we could have made was rely on our automated failover muscle. And the downside to that is that if we get into a gray failure scenario, it could take a little bit longer to recover. The other option is to proactively switch over. And what this does is it allows our databases time to fail out. And take, for instance, we have an active in San Antonio and 3 other copies. One is out for deployment, which we do frequently to make sure they have the latest builds. And then we have 2 other hardware failures. I know that seems improbable, but at this scale, it happens. The other benefit of doing that is that we can halt non-discretionary maintenance from going on in the other locations so that those databases have the best place to go. The con is that we're operating at a reduced capacity, so we're taking out a quarter of our DAG. but we are designed to handle that. If we're at that level for an extended time, we might have to back off on some of those deployments, for instance, which is not ideal, but we can survive. So we decided to proactively switch over. And the graph on the right shows how we performed. The black line is the number of databases in San Antonio before we made that decision. And you can see it drops off rapidly. The solid filled lines are where those databases ended up in the rest of North America. So we moved 43,000 databases out of San Antonio in under 20 minutes with no impact to our monthly availability. I think that's pretty impressive. Thanks. So how is such a large feat so routine? We exercise this code all the time by design. For instance, we move 1.2 million databases every day. A lot of them are administrative for things like deployment, and we also do it for failover reasons as well. So we stayed switched out for days without any redundancy alerts and sustained our high availability. And it wasn't like it was a wasted effort, because just like we exercise the failovers regularly and rack switchovers regularly, about quarterly we try to do a whole location switchover as well. So if we hadn't done this for San Antonio, I would have picked another data center. And one of the last ones I did was the largest data center for us in the world. So we're not afraid to do this often and with our biggest data centers. So next, I'm going to hand it over to Lynn.
Thank you, Kathleen. Hi, everybody. My name is Lynn Chen, and I'm the Program Manager Lead for this area in HAN storage. And I'm super excited to be back at Ignite, to be able to go and have an opportunity to talk to you about all the cool stuff that we've been doing in HAN storage. So a little bit of a warning, because both Kathleen and I come from a very technical background. We're going to geek out a little bit today and give you some insights into how features work, not just a list of features that we're going to release to you, but how they actually work. And I think it's important to understand that when you're using Exchange. So let's start with workloads. So in order for the Exchange service to work functional, there's a lot of different things that are working on your mailbox server. So whether these things are there to go and replace your databases, to restore redundancy, to check if there are any corruptions, or machine learning activities that are there to classify your emails as focused or not focused. All of these stuff is running there, but we also know that there's a lot of workloads that are client-facing. So those client interactive workloads needs to happen super fast. So how do we make sure that we still have fast client interactive workload while we still have all of the other workloads running in the background and not interrupting those things that are more important? Well, we have this awesome component called workload management. This is what we call WLM. So what WLM does is that it dynamically manages workloads based on the resource availability. So because we know exactly what type of workloads are there and what they do, we can go and classify them into different priorities. So if we look at all of the things that's running, anything that has any sort of user response, those ones will be classified as urgent. And anything that doesn't need immediate responses, we can push them off to execute at a later time. So when we look at WLM, we can then go and say, okay, when the users are using Exchange during 9 to 5, we should save the resources for those activities and push the machine learning and corruption detection off to something later. So if we look at the diagram on the right, when we have WLM, then we're able to shave the peaks and fill the valleys. So how do we use WLM? We have a bunch of resources. And you've seen most of these resources before, and they've been there for a while, but we have some new ones that we're going to talk about in the next few slides. So the first giveaway I'm going to have. So hands up if you know what database reseeding is. Oh, awesome. So some... So who can, so hands up again. I'm going to pick somebody. Okay, you. What is it?
Recreating a
Fantastic, awesome. So come up later and then you'll get a book from Tony Redmond. So yes, exactly. So we do database reseeds all the time because we have to recreate that copy if it's failed from the active database. We do auto reseeds, and you should also do auto reseeds. We do about 2,000 of these reseeds every day. And as you can imagine, this reseed can be disk I/O intensive and CPU intensive. And if we were doing this in the middle of the day when all the users are using Exchange, this is going to cause a bit of an issue for those users. So before, this was not server health aware. So what is our solution? Well, because we have WLM, we're going to hook it up and we're going to throttle reseed throughput using WLM, in this case, CPU and I/O latency monitor. And since reseed is there to restore our database redundancy, we don't want that delaying of the reseed to actually cause it to the redundancy to go down. So we have some safeguards in place. And one of them is that this is configurable so that if you need to stop it for whatever reason, stop throttling for whatever reason, you can do that. And the other one is that we will only throttle you if the database, all of the other copies are still healthy. So I'm going to walk you through an example. This is actually taken from our production servers. So if you look at these lines, the orange line is representing the disk latency, and the red line is representing the seed throughput. And the blue line there, that is the disk latency throttle threshold. So right now it's set to 0.04, 40 milliseconds. What we're saying is that around about 40 milliseconds, we're saying the disk is kind of busy, so anything that is not critical should back off so that we can let the user interactive loads go first. So around about 140, we see that disk latency has crossed that threshold. So that signal gets sent to WLM monitor, and the monitor says, reseed, you need to pull back a little bit. So we see that reseed throughput drop, and it stays dropped because the latency is still high. So around about 240, the latency goes down below the threshold, and that signal gets pushed through to WLM again. And at that time, it says, we're all good. You can go ahead and continue your reseed. It's a pretty simple concept, right? But this concept and this is able to help us protect the user experience when when resources are critical. So next, DB divergence scan. So some of you may recognize this. This is something that we released in Exchange 2016. So DB divergence scan, or DB scan as we call it, is a feature that is there to detect DB logical corruption. So what this does is that it actually goes and scans every single copy of the database and compares them to see if they're the same or if there's a divergence. And if there is a divergence, it means that there's a corruption. We go and fix it, and so on and so forth. So this thing runs in the background 24/7. It runs all the time. So before, this was statically throttled. So what it means is that we let it go for a period of time, and then we stop, and then we let it go again. As you can imagine, this is I/O intensive because it's looking at all copies, right? And it's not system health aware. So what is our solution? Well, we have WLM again. So we are going to hook this up to WLM so that we can dynamically throttle when we can do DB scan. So some of you may have picked this up by now, but for this particular scenario, our traditional monitors are not really enough. Why? Because those traditional monitors are only looking at the resources on the active copy. But this guy is doing work, intense work, on all 4 copies of the database. So for this, if we're only looking at the active and then saying, oh, you look healthy, you go and do your work, we're basically sending out its passive copies to be really bad neighbors, right? So we had to go and create a new monitor, and this is called the database read latency monitor. So if we look at this example, we've got, if we're trying to do DB scan on DB0, so it's got the 4 copies, and each one of them are on one separate disk on their own servers. So we see that the active is healthy, but the disks where one of its passive is located is unhealthy. So in this case, again, if we wanted that passive to go, that guy is going to affect DB3 on that unhealthy disk, right? So all of that signal gets sent to DB read latency monitor, and it says, well, only 3 out of 4 is healthy, so I'm going to say this is unhealthy, don't do any work. So we stop the DB scan. A few minutes later, we see that, oh, right now, all 4 copies are now healthy. And so that is when the monitor goes and tells the DB scan workload to say, okay, right now, everything's good. You can go and start scanning. So again, super simple concept, but this is able to help us protect your experience when you're using Exchange. Next thing I'm going to go through is database rebalancing. So we can get into the situations where a server can just get a lot of active users on that same server at the same time. So when that happens, all these users are competing for the same resources, and it is going to give you a bad experience. We do have load balancing for migration purposes that if we see too many users, too much space on the same server or same DAG, we go and try to move them out. But this is not something that's immediate mitigation. And we also do have existing load balancing, but it's only based on preference copies. So we created a new database rebalancer that actually proactively rebalances DBs based on the CPU utilization. So again, I wanted to walk you through an example. And this is, again, taken from our production server. So if we look at the bottom, the blue line represents the CPU utilization, and the orange line is how many databases are actually mounted on that server. So the rebalancer runs on the PAM every 10 minutes. So at 6:30, we see that there are 11 databases mounted on that server, and the CPU is actually at 99%. So that's pretty busy, right? So users are not having a great experience right now. So a few minutes later, rebalancer runs, and it sees this situation, and it sees that the rebalancer trigger for CPU has been hit, which is at 99% right there. So it's trying to do some mitigation. So what it does is that it goes and tries to move some of the databases off of that server, and every time we try to move that, the maximum number of databases we move is 2, because we don't want that server to be oscillating between like CPU utilization. So it moves off 2, and now we only have 9 databases on the server. But you see that the CPU utilization is still pretty high. So 10 minutes later, rebalancer runs again, and it moves up 2 more databases. So now we're at 7 databases on that server, and finally, 5 minutes later, that server becomes healthy, and it's at 89% utilization. So again, very simple concept, but it's really helping us in terms of making your experience better when you're using Exchange. So I'm going to give this back to Kathleen to talk about another new monitor that we've got.
Yeah, so the off-box resource I'm going to discuss is networking. So if you attended Monday's session, you already know the scenario, but I'll repeat it again. So in Europe, we plan for a single link failure, just due to historical analysis of what's likely or not. In other regions, we may plan for more. But in this case, we actually had 2 out of our 3 links from Helsinki go down. This would have been catastrophic had we not built in our automated features. We recovered automatically without human intervention or knowledge of how long it would take for any of the fiber to be repaired. So in this graph, the top line represents one of the Helsinki to Stockholm links that was cut due to road construction, and that was repaired within a day. The second link was Helsinki to Frankfurt, and that was a submarine cut that took weeks to fix. The remaining link to Helsinki to Stockholm started taking on that all the load from the other links, and it wasn't designed to handle that much, so we started to see some network health degradation. So the first automated recovery action is one that we're all familiar with here, and that's our HA solution. So within the DAG, we noticed RPC failures and started activating those databases in servers outside of Helsinki. The second recovery action which is new, is we started dropping our lag traffic to give priority to our other traffic. The third recovery action utilizes that new WLM monitor that Lynn just mentioned, which is our network resource health. So in this event that happened last month, the network resource went critical. Those are the red and black indicators on the graph there. And as a result, our discretionary workloads that listen to this monitor and push traffic back off. So that graph is our gigabits per second leaving Helsinki, and you see that dip right after 10 o'clock. Our last recovery action is a rack switchover. So you can see that after all of these recovery actions, the network health became green even before any of the fibers was repaired without any human intervention. So I'm going to walk you through the new features 2 through 4. Lag is scavenge. So we specify lag as lower priority traffic. And what that means is that it automatically gets delayed during congestion scenarios. And what you'll see happening is the copy queues will start to build up. And they'll catch up due to the nature of replication after the network becomes healthy again. Now, as we know, lag is the fourth back-in-time copy, so we considered it discretionary so that we can give priority to your user interactive traffic. Implementation-wise, we had to create a specific port just for lag replication and then mark it with DSCP 8. This diagram is an architecture of the WLM network throttling feature. If we start with the box kind of in the upper left, the network resource state, that state gets pushed to Azure storage tables. So we have as a DC to DC basis what the health is of the link from a score of 1 to 101. That gets pushed to a new component called Network Throttling Manager that it resides within the PAM. And we use the PAM to replicate the state to all other nodes in the DAG. And by the time that's done, all of the servers in an entire location know what the state is for all the links. So WLM now knows the state of the network health and talks to the discretionary workloads or the consumers of WLM. And some of the consumers, like migration, are aware of our replication footprint. For example, if we wanted to load balance and move a mailbox from Amsterdam to Dublin, we would stop that because we know that in Dublin it would replicate to sites like Helsinki. And since Helsinki the health is bad, we would stop the Amsterdam to Dublin replication there. The other thing that you'll see on the left is we consolidate the health of the network that we get from the servers themselves, such as packet drops and the percent of racks switched out for that location. So the important thing to note there is in the Helsinki scenario, we use that packet drop signal that we got based off of Exchange server information alone. We didn't have a dependency on any other networking information there. The upper left is another signal that we use, not in the Helsinki scenario, but we can set a network utilization threshold to stay under. And we've done that in scenarios where we're doing extensive network maintenance and where we need to reduce the amount of traffic. So we'll set a cap to allow that maintenance to occur. The last recovery action I'm going to talk about is at the machine and rack level. So we have a lot of signals on our equipment that look at things like packet drop, latency, outside communication points, or smoke tests or app pools to see if to test the health of the network. And based off of those signals, we have different thresholds and recovery actions. We could reboot or restart services, send a machine to get tested to see what's wrong, and rack switch over. So in the Helsinki case, we saw a bunch of machines go unhealthy. And instead of sending them individually for repair, we automatically elevated to a rack level issue. And then from there, we saw a bunch of racks go unhealthy, and then saw a DC issue. So 2 things happened in this case. First, our network resource health went critical, and that's what I showed you in the beginning. And secondly, after some successive network degradation signals, we then decided to automatically switch out the racks. So what that meant is that the databases will move off into the other locations. And the other benefit is that it keeps the databases from coming back to those Helsinki servers until those racks can pass the network tests, and we've deemed that everything's healthy. So from this section, the main takeaway is that we're continuously translating our learnings from the cloud to help improve the quality for on-prem. So we took you through a whole site switchover scenario and showed you that we can fail out of hundreds of racks and thousands of servers like it was nothing, no big deal. Then we walked you through some of the optimizations we do for resource consumption. And lastly, the automated recovery from a gray failure we showed you there. So this next section is about innovations in storage. And the first one is our Bing-powered Exchange Online search. And the big difference for storage with this feature is that we went from having a separate search stack to having search native to Exchange. So I'll show you what that looks like. Well, actually, first I'll tell you a little bit why that was a problem for us at scale. So when we have 2 separate stacks, we're basically managing 2 different sets of code. We have 2 HA solutions, 2 storage, 2 replication systems, and that just adds more complexity that we don't need for similar functionality. The other one is compliance boundaries. So with separate search stacks, your search indices don't reside within the mailbox. And if you have a scenario where you need to be able to take control of your keys to encrypt your mailboxes and your data, you won't be able to separately encrypt your search indices. And the last one is about resource consumption. So right now in the current architecture with 2 separate stacks, we have to allocate memory for the entire database since we use a database-wide index, which means that we're doing the work for indexing mailboxes that might be inactive or might not need it. So a little bit of a waste there. So for the separate search stack, we have, when mail comes in and is written to the mailbox, we have this indexing assistant in green that does all the work to transform the mail into the search indexes that you need. And then that full text index gets stored on the file system. And it is protected by BitLocker, but if you went to some of the earlier talks, you know that Windows Server admin still has access to that data. So this is the depiction of the mail coming in. And then for the replication story, we use log shipping to send the mailboxes out, but then all the passive copies go through that ingestion loop to do their replication. And the other issue with this design as well is that the indexing assistant could build up queues. And if there is a queue and a query comes in, that mail might not be eligible for those results because it hasn't quite been indexed yet. With our integrated search stack, called codename BigFunnel, the mail gets delivered with the data structures directly into the mailbox. And I'll show you next how that happens. And you can see there that the same keys that encrypt the mailbox also will encrypt those data structures themselves. And that's and you can then utilize the service encryption feature. And here, the replication story is simple and easy, using log shipping. So here's the indexing flow that I was talking about with BigFunnel. So the mail comes in through the protocols and then gets word broken, the content's transformed, and we create this POI, per object index file, and it's basically an optimized, normalized representation of the object's forward index. So all of that gets created and stored directly into the mailbox and replicated. And because it's done basically real time, the queues don't build up, and the mail is eligible when there's a query. It gets pulled as a result and sent back right away. So service encryption. Who here went to the talk where this was announced? Or any of the talks where this was announced? Okay, I might have a question for some of you guys coming up. But essentially, this enables customers to provide and manage their own keys. So they can update them or revoke them, and that's at a per mailbox level. So now you can see that because the big funnel architecture puts that content on the mailbox, it now becomes encrypted and eligible for service encryption. So this talks about customer managed keys, but Microsoft also can manage your keys for you. Can anyone tell me where those keys must reside, though? You went to the talk? Yeah, exactly. Cool. So give us your card after for the book. So let's talk a little bit about how this partnership with Bing really helps out. So on the left, we see that Bing has done a lot of work in its web search to leverage accessing a bunch of data at that scale and variety of data. And we're applying that technology to your O365 content, so very powerful there. So some of the search scenarios in tech that we talk about, one of them is smart captions. So on the right, you see a query. You type in photos Robin. And before, you would get a static caption. So let's say the first mail might say, thanks everyone for coming to the all hands event, but that text that says check out the photos might be deep within the message and wouldn't show there. And that was because before we only had the inverted index, which pointed the content to the document. Now we have that plus the POI, which that's on each page that points back to the content. So your caption is now specific to your query. So if you typed in all hands, you would see that. If you typed in photos Robin, you'd see checkout photos. So that really helps you find what you're looking for a lot faster. Other technologies that we're bringing from Bing are advanced ranking and better relevance. The other scenario is dynamic indexing. Before, when we had a new search scenario, we had to tie it to a build, and a build in Exchange Online can take up to 2 weeks to deploy. Now, we just stamp our scenario with an extension, and when that mail comes in with that extension, it automatically gets indexed. So there's no more waiting. It's a lot faster scenarios, which will help with innovation there. So to wrap up with the benefits for BigFunnel, search execution is twice as fast because of some of the indexing architecture, the querying and indexing technology from Bing, but also we're putting our message tables on SSDs through the MCDB feature, which Lynn's going to talk about next. We're more efficient because we have to allocate less memory because we're doing it per mailbox. We're more secure in that service encryption can now be applied to your search data. We're simpler because we now have one HA solution, same replication, same storage. We don't have to maintain 2 sets of code. And it's powerful because we're using world-class web search and world-class messaging combined. So we're bringing the best of Bing technology into O365. So we're successfully rolling out BigFunnel and Exchange Online. Half of our mailbox is already there. So I hope you guys are just as excited about this new feature as we are, and that you will also be excited about the next one Lynn's going to talk about.
Thank you, Kathleen. Kathleen and I have been working together for about a year and a half. And at work, sometimes people actually get us confused because we both work for HA and we both have like dark hair or something. I don't know. No, but true story though. But what they don't actually know is that we do actually have a lot in common. We both started our careers in the defense industry. And not only that, we both worked on the same military data link technology. And even further than that, we actually worked on the same specific military link technology. And unfortunately, I can't tell you what that is here. The thing is that she was a systems engineer for Raytheon, working on the US data link system, and I was a software engineer at BAE Systems, working on the Australian data link system. So we could be here geeking out about military data links here, but I think you guys want to hear about SSDs instead. So if you went to the keynote session on Monday, you would have heard about this awesome feature called MCDB. And we're super excited about it because it's been running on the service for a while, and we've seen some awesome results. So I wanted to start with talking a little bit about, why and how we came up with this thing. So we've seen industry trends that is telling us that hard drives, is getting larger, but they're not getting faster. While, we have these 10 terabyte and 12 terabyte drives, we're using 10 terabyte drives now, and we'll be using 12 terabyte drives very, very shortly in the service. While they're getting bigger, they're not getting much faster. And while we're seeing like CPU and memory growing really, really fast, and they're getting really, really great, this I/O, this hard drive limitation is kind of impacting our user latency. So how do we make our hard drives go faster? Well, we know SSDs are faster. We know SSDs are much, much faster than HDDs. And we know, however, that SSDs are more expensive than hard drives. So we went back and looked at our data set. And we actually see that, if you see that blue circle there, that 90% of our data is message bodies and attachments. And only a very small percentage of that is latency-sensitive data. So we said, okay, so why don't we supplement a mailbox server with both HDDs and SSDs? And really a small percentage of SSDs is able to decrease our user latency. So this is why we came up with this feature, MCDB, that is able to put HDDs and SSDs to great use. So I want to clarify that in case you didn't get this message, Exchange is not replacing our servers with SSDs. We're only supplementing it with SSDs. So we're going to have both hard drives and SSDs in our server. So Metacache database, this is our intelligent app-based storage tiering solution. We're going to be using this to accelerate latency-sensitive scenarios. We're going to be able to go and identify those common operations, not only accelerate their latency, but we're able to go and offload HDD I/O with that. And once we offload those HDD I/Os, we can then increase our mailbox density, and doing all of that without breaking the bank, right? We can do this because we know exactly what data is stored and where that is stored and how it's accessed and any sort of access patterns that we see. So traditional storage tiering systems can't do that because they are not aware of the context of that data. So what is MCDB? Well, MCDB is actually just a secondary database for each of your matching primary databases. So we store high-value metadata in the secondary databases. And MCDB resides on the SSDs, while your primary database stays on the HDDs. So whenever we have these eligible high-value scenarios, those reads can come directly from the SSDs and be much faster in terms of access and avoid HDD reads altogether. So when I say high value, these are things that are latency sensitive and things that are common to a lot of other scenarios. So if you look at the layout here, in the service, we have 4 databases per each hard drive, and we map 2 drives worth of databases into a single SSD. So one SSD has 8 MCDBs. So when we think about what do we actually put into the MCDBs and accelerate that, our principle is that the data that's there needs to help with the application context. So these are the things, these are the metadata that will help specific targeted scenarios to be faster. This is not a traditional caching system. So just because you're accessing that particular piece of data very frequently, we're not just going to cache that. We're caching it based on a scenario. So if we look at the specific things that we're putting in the MCDB, what we cache here is the full message data full message table on page data. So this is the thing that we get when you have a preview, when you do a search, and it comes up with that first part of the message. So it has the title, it's got the header, date, and the preview. This is able to enable us to have faster index search, which is the feature that's supporting Big Funnel, like what Kathleen was talking about before. And we also cache mailbox tables and user info tables. They're there to make our mailbox and user logon a much faster scenario. What we don't cache, this is that 90% of the message bodies and the attachment that I was talking about. Those scenarios are not high value. We still leave them on the HDDs. So when we look at this data, we can see that a very, very small percentage of SSDs can help us decrease the latency for these scenarios. So we generally have a 100 gig MCDB for a 2 terabyte database. So it's around about 5%. So we look at how MCDB actually works. So the first scenario we have here is how do we actually populate an MCDB? So if you look at the gray database on the left, that's your primary database. That's got everything, all the data that's in there. And then if you look at the SSD, the MCDB part, it's only got a subset of what you have in the HDDs. So when we go and say we're reading A, or we've got something coming in for A, and when that gets updated, the data is written to both the primary database and the MCDB at the same time. So this is what we call, so A is what we call MCDB eligible. So now, when we go and update B, you'll see that B is not part of MCDB, and therefore it's not MCDB eligible. So when we update B, it just updates B in the primary database as per normal. So now this is the part that gets very interesting. This is when we go and read data. So A, as we knew before, A is in the primary database as well as the MCDB database. So when we read A, we're going to read directly from the MCDB on the SSDs. So we're completely avoiding accessing the HDD for that scenario. So this improves latency, and it just saved us that I/O from the hard drive. If we read from B, because B is MCDB ineligible, we just read it from the HDDs. No difference there. So what happens if we have an SSD failure? Well, because the data is in both of the databases, when we read from A can still be served from the hard drive. And in this case, the availability of that read is not compromised. So we're still able to serve all of the data from your primary databases. So here's some results that we've seen with some examples that some scenarios that we've accelerated. So the first one, this is our Big Funnel, the better search experience scenario. So for Big Funnel, we have put all the key metadata, the message table on the MCDB. So before, without the MCDB, each index search results in 25 random item seeks from the hard drive, right? That's pretty slow. So with MCDB, because it's on the SSD now, all of the results are bounded directly from the message table on the SSDs. So if we look at the results, we actually have seen a 50% latency improvement in your searches. This is awesome, and it will come to you very, very soon. So the next example, this is kind of the offloading IOs from common operations part. So mailbox logon, whenever we need to do anything useful, we have to go and log on to the mailbox. So there's not just user logging onto the mailbox, but there's things like time-based assistance, where it's going through each of the mailbox and doing things to it. A lot of things that are using that. So not only when we go and offload the mailbox tables into the SSD, not only are we accelerating all of these scenarios, we're actually saving I/O from the hard drive. So if you look at the graph on the right, that big drop, that 50% latency improvement is when we first released the feature. And at that time, we measured how much HDD we had, and that was a 9% overall HDD. So that 9% can go and serve other scenarios.
Hey, Lynn, that's great. Great improvement there. Do you have anything for the traditional cache, though? Any improvements?
I do. So, so that was SSD caching. So now we know that memory has improved, right? So we should go and take advantage of that as well, right? So here we have DB cache priority. So now get your mind out of the SSD caching. Now this is a bit more of a traditional cache. So we're using our DRAM here. So as you know, easy databases have a DB cache, and we put that onto the memory. And it stores most frequently accessed pages there. This is using the least recently used variant, and basically it is it's a cache that caches the pages that are frequently accessed gets to stay in the cache for a lot longer. So this is completely different from what we just talked about in terms of MCDB. So this reduces read latency from the most frequently accessed data, and it is able to go and avoid accessing pages from HDD IOs. Let's take a quick look at how this works. So we have stale pages, we have fresh pages, and we kick out the stale pages when they're not needed anymore, when the new pages are coming in. So if we look at these, the purple page at the end, he's 100. So let's just say that he's 100 years old. So he's old and stale. So we have some new kids coming into the cache. They're 1 and 2 years old. So they come in, and what happens? They kick out those old guys, right? No respect for old people these days, right? So, I know, poor Mr. Purple Page. Anyway, so they come into the cache, and they have a great time. But as time goes on, they age as well, right? They get to be 199. But because Mr. Green Page is super popular, he gets asked to be, read again. So now he gets to be in the front of the page because he's frequently accessed, and he gets to enjoy that time in the cache all over again. So when the next page comes in, his friend gets kicked out, and he's still there, right? So this is our traditional database caching algorithm. So we have taken this one step further, because we know exactly how things are used and what is high priority and what is lower priority. So it's a pretty simple concept. Lower priority pages get evicted faster, and higher priorities pages get to stay in it for longer. So we have identified 2 types of low priority pages. And one, this is pretty obvious, like what we had before, if you're non-user interactive, you can be delayed. So you're not so latency sensitive. So in this case, time-based assistants, because they can be delayed later on, they're doing machine learning or something like that, they don't have to serve that I/O straight away. So we're going to push them to be like the lowest 10% of the page. And then we're going to also deprioritize MCDB pages. So I'm sure people are gonna be like, hey, you just told me you're putting all the high value data into MCDB. Why are you now deprioritizing all this stuff from MCDB? Well, if we think of this as like 3 layers, you've got your memory, you've got your SSDs, and you've got your HDDs. So you're putting as much page, all the frequently accessed page on the top layer, which is the memory. But if you're an MCDB page, you're already pretty fast, right? You're already pretty latency, like pretty short latency when you're trying to access that. So a miss in the SSDs, a cache miss for SSDs is way cheaper than if you are missing that cache if you're accessing it from the hard drive, right? So we're saying we're okay with you being out faster because we're going to save those for those pages getting access from the hard drive. So we're going to evict MCDB pages a lot faster than everybody else. So some benefits that we've seen is that the user interactive load now stays in the cache for 50% longer. And what that means is that it's lowering overall disk latency. It's providing better latency for those targeted scenarios, of course. And then when we look at the MCDB targeted scenarios, even when we go and evict them much faster, there is actually no impact in terms of those SSD latencies. So let's take a look at how this works in this brave new world. So I want you to pay attention to the purple page and its age. So here it comes back again. He's 97 years old this time. And, yes. And our popular Mr. Green page comes in, but in this new world, he's actually an MCDB page. So even though he is 1, he gets to be deprioritized at the very, very end of the queue. So he only really stays in the queue for 5% of the time that the entire queue can sustain. So he comes in and he gets to be at the end. And purple page turns 1 year older, so he's 98, and he hasn't actually moved, right? So another page comes in. This time, this is the TBA page. He's also not very important, so he gets a low priority at 10%. So when he came in, he kicked out the MCDB page, even though MCDB page just came in. And you see purple page turns 99, and he's still at the same position in this queue. So he hasn't moved because he's important. So more TBA pages come in, and it kicks out the the orange page that we just put in there, again, because he's not as important. And purple page now turns 102, and he's still in the queue, again, because he is high priority, and we want his scenario to complete first. So some takeaways in this section: we're continuously investing in our future technology for storage. We have BigFunnel, which is a fully integrated search stack, and it's leveraging Bing technology. And also, Exchange is leveraging SSDs, and we've created our own app-based storage tiering system that is able to get higher value scenarios, better latency, and a path to higher mailbox density per disk. So in our last section here, I wanted to give you some tips for your IT pros. So, show of hands, who is a Exchange administrator? Ooh, there's lots of you. So keep your hands up if you've ever been asked to restore or find deleted mails. Oh, there's lots of you. Okay, who loves this experience right now? No one. Oh, you do. I'm sorry. Okay. That's good. We should talk afterwards. I was gonna maybe this next section is not for you. You might need to get out, but I don't know. But I know we've heard from you that this experience is really not very ideal. So we've created something good for you. So something that you hopefully you'll like. So for all of those that have gone through this, you've been called to find missing mail, whether it's because somebody somebody accidentally deleted it, or it's your retention policy changed, or you had to do a search and destroy action, and you have to recover things in bulk for those users. And searching and restoring items is hard, as you have all just told me. Firstly, you can't search in recover deleted items folder, right? So there's a UI, and you have to eyeball it, and you have to, there's thousands of items in there. You can't find it. So even if you found those, you can't actually restore that mail back to the user's mailbox, because you have to go and create this PST file, you have to transfer it to them, and then if they don't know how to restore PST files, you have to walk through all of those processes with them, right? So even after you've done that, if they had created this nice folder structure, that email is not going to go back to that folder structure. So they're going to be like, oh, I don't know where my mail is. You told me you restore it, but it's not there. So this is very frustrating. And then for you, if you actually had to go and restore stuff for users in bulk, you can't actually do that either. You have to call Microsoft and say, hey, can you do this for me? So we've created these two commandlets for you, the get recoverable items and the restore recoverable items. So now you can use these commandlets to go and search for deleted items and recover deleted items folder directly without user interaction. And once you do that, you can actually go and restore those deleted items directly to their original folder location. And you can go and control the type and the amount of items that's stored. And then, last but not least, you can actually go and write custom scripts and wrap whatever you need to do for restore recoverable items and restore things in bulk. So let's walk through just a couple of scenarios. So we have Paula here, who is a sales executive, and she is doing this big presentation tomorrow, and she's not able to find this email that's containing all these crucial information. So she is panicking, and she's calling her IT support person for help. So Bob here is her Exchange administrator, and Bob's like, oh, no worries. I've got these two awesome commandlets that Microsoft just gave me, and I'll get you out the door in like 2 minutes. So Tom just asks for some information, as much information as Paula can give him about that particular email that she wants. So she knows that the subject contains FY17, and it was seen around like September 5th. And she also kind of knew where that mail was located. So Tom goes and uses that information to craft a get recoverable items commandlet. So you see it here. So get recoverable items, you can put the identity, who it is, and you can put a subject. You can filter on items, so this is a mail, so it's an IPM.note. And then you can also put a time frame for that particular, for when that mail disappeared, right? So he runs that commandlet, oops, and he gets two results. So in here, you see that the results is displaying the subject and where that mail was coming from, and the original folder where that mail was. And because Paula told him where that original folder was, he sees that, oh, it's that first mail, the FY17 accounting sales mail that she really needs. So next, Tom just goes and crafts a restore recoverable items commandlet, and tries to restore it from there. So you can do restore recoverable items in many ways. You can just put the item ID in there too, but I wanted to show you that you can put additional parameters there, like source folder. This time it's recoverable items. We can put it in there, and you execute it, and the mail is instantly restored to her mailbox in that particular folder that she had it from. So Paula says, thank you, Tom. That was like super easy. I don't know, like, Tom, right? So I don't know, like Exchange administrators, they've got so much free time on their hands. I don't know what they're going to do, right? So now next, we have a restore mail for bulk users. So this is another Exchange administrator, Bob. So on September 1st, he gets a call from an auditor and says, oh my gosh, I did a big oops, and I sent mail that was with sensitive information to like the entire company. And I really needed to send it to this group of auditors that I work with. So Tom's like, oh, it's fine, don't worry. And so he took a couple of mitigations. Firstly, he did a search and destroy, and he went and deleted that mail from everybody in the organization. But he didn't stop there. The second step, he actually did two things. He found, because he knew that this email was intended to go to some people, he went and grabbed all of the people that mail is supposed to go to, put it in a CSV file, and then he went and wrapped the restore recoverable items into his own commandlet so that you can go through each person and restore that mail to those people. So super simple, and he was able to go and recover that So he was able to restore that mail to the auditor team that needed that email. So a few benefits from here, right? So of course, first benefit, you can go and restore things in bulk for users. Secondly, if those users had moved that mail to a different folder, this commandlet went and restored that mail to those folders. So really, those guys wouldn't even have known that the mail was gone and then it came back. So all of this recovery action that Bob did had limited visibility to the users at the end. So this is something that you guys can use, and hopefully, and this is something that will be coming out very, very soon. So I wanted to give back to Kathleen to tell you about more HA tips.
Yeah, so who here is afraid of bug checks on their servers? Anyone? Hey, you want to tell me why? Oh, guess not. Anyone? Yeah. Oh, sure, yeah. So bug checks for us in Exchange are actually a form of recovery, and it helps us recover from hung I/O and hung system and data drives. So they shouldn't be feared, but we should be transparent. And what was happening before is we noticed that Exchange servers would bug check, and customers would send these large dump files to Windows support. And Windows support would go through it and then determine, hey, it was actually Exchange. And that's not a very pleasant experience for anyone. Now we've implemented two best effort events that clue you in to what's going on. The first one is the server that bug checks actually flushes this information to disk so that when it comes back up, it reconstitutes that event and puts it in the system drive. The other event that happens is an RPC to all the other nodes in the DAG that tells you that that server bug checked and why. So now if you leave the party, people are going to notice. So earlier, Scott told you guys that the reboot responder was broken in 2016. Actually, we just fixed that and validated it a few days ago. So there you go. And we like that because, again, bug checking is a form of recovery, so we're glad we're able to do that. Next, I'm going to tell you about a couple augments to get mailbox database copy status. This one is about availability and redundancy validation. So let's say you're doing request begin maintenance and it fails and it gives you the database. Now you can troubleshoot why that happened by piping out this check failed error message. So here, the reason that that database failed is that testing suspend. So that looks like someone free text formed that. If it was automated, it would probably be longer, right? So you go to your colleague and you're like, were you doing some sort of testing on this database? He's like, oh, yeah, I just forgot to resume the copy. I was doing this last week, and I put in the suspend comment as testing suspend. So this just helps you with troubleshooting a little bit. Another one is, so the average disk read and write latency, as well as CPU utilization, is now part of copy status as well. And Lynn told you about some of the features that WLM uses, like the rebalancing and DB divergence scan, that use this information. Well, we make it available to you as well. So this is measured every 5 seconds, and what's displayed is the rolling 5-minute average. So that white box is an output of the CPU percentage there. So let's say you're noticing a bunch of high replay queues on the same server, and those databases are sequential, so it might be a disk problem. So again, you pipe out the disk rate latency, and whoa, 204, that's pretty high. And if you have access to historical data, you can see it was, in fact, high for quite a number of hours. And in Exchange Online, we have a repair box component that detects the errors like this. So it actually identified the port and automatically created a ticket. So I was just talking to some customers the other day and heard that you guys would like a better way to monitor the health of database drives. We have that repair box component, but you guys might not have that. So we have an event in our high availability seeding log that's 1149 through the disk reclaimer that will actually show you, identify the status of different drives and whether or not they're used or unused. So if you want to build something like that for yourself, you can build a script that queries that event, identifies the drives, and then begin your own repair process, whether that's filing a ticket or whatever you deem is necessary. Next, we have test replication health, we're all familiar with, but you can now enter the DAG as the parameter instead of the server. So this saves you from having to loop through all the servers and look at that big, long output. It consolidates it for you and identifies which servers failed those checks. So you got that happy guy in the middle with the consolidated results for everybody right there. So I wanted to thank you guys all for coming to our session. And the first part was all about our improving client experience, sort of the more traditional HA storage things. And then we went into details about our storage innovations to enable new and better experience. And lastly, we're listening to you IT pros and developing features that make it easier for you to administer Exchange. So as we know, Exchange 2019 is coming out. So in our eval, if there's any features that you really liked here and want to see on-prem, please let us know what they are and what the value add would be for you, and we'll take that into consideration for our roadmaps. So we're gonna, with the time left, we're actually gonna take questions offline, and please take the time also to fill out the survey. And that's that. Thank you.